Genetics 1. Chapter 3 Genetics 1. Genetics, the branch of biology in which the heredity and variation of traits in living organisms is studied, is called genetics or genetics. Batson first used the term genetics. 2. Genetic traits, those traits that carry generation to generation transmission through sexual reproduction. 3. Heredity. The transmission of genetic traits from parent to child generation is called heredity. Spencer used the word heredity. 4. Due to gene exchange in sexual reproduction, mutual differences are found between living organisms of the same caste. 5. Gregor John Mendel is called the father of genetics. He used hybridization experiments on garden peas. Their experiments were presented to the Brunn Society of Natural History. In 1866, they were published in the annuity of this society under the name of Plant Hybridization Experiment. 6. Rediscovering the rules of the Medelzuko. The Bries, Karl Correns of Germany and Erich von Schermach of Austria performed different tasks. 7. Mendelism. The rules of genetic inheritance are called Mendelism. Key features of pea plant selected for Mendel's experiments. Selection of barred plant for hybridization experiments. 1. Pea is a one-year plant. 2. The size of the plant is small. 3. The seed has a high number of seeds. 4. The mother is a hingering plant. Self-pollination is found. 5. Pollination occurs easily in the flowers of the mother. 6. The plants of the mother have many different external effects. Use of Mendel. A. Hybridization. The hybridization done after taking into account a pair of divergent traits such as plant length, long and dwarf. Mendel selected the pure tall and pure dwarf plant to hybridize. Pure long elves TTTT pairing. All the plants of the F generation derived from their hybridization were tall. The symptoms which did not appear were called ineffective symptoms, and those which appeared were called effective factors. Here the symptom of elongation is effective and dwarfism is ineffective. All the generations of generations are heterozygous TT. Mendel made F1 generation among his offspring and got second generation F2. Both types of plants were produced in F2. The F2 generation has a symptom type ratio of 3:1 and a John-wise ratio is 1:1. A gross hybridization. 1. Rule of effectiveness. When a plant is hybridized with the combined antipyretic symptom, a symptom is caught in the generation, it is called an effective symptom. Those symptoms which do not appear in the F1 generation are called ineffective symptoms. 2. Rule of purification or purity of pairs. Both symptoms appear in F2 generation during breeding. 2 rules given on the basis of improvement are called pure sexual times in the rule of effectiveness. The separation of gametes at the time of formation of gametes is called separation. A hybrid progeny is heterozygous, in which both factors of the causative pair coexist but the same factor is present in a coupler at the time of gamete formation. Hence it is also called the law of purity of the gametes. Bivalent hybridization. Hybridization taking into account two added antitrust traits is called bivalent hybridization, such as the shape of the seed and the color of the seed. Mendel hybridized plants with pure round and yellow seeds RRYY of peas, pure Jacinda, and orchestrated by plants with green seeds RRYY. Round and yellow seed RRYY plants were obtained in F1 generation, that is, round and yellow seed factors were effective and the wrinkled and green factor was ineffective. F2 by self-pollinating F1 generation plants. The above-mentioned 4 factors of F1 generations of plants obtained spontaneously appeared in F2 generation, i.e. their seeds were round yellow. The ratio according to its John was 1:2, 4:1, 2:1, 2:1. Bivalent hybridization. Note 12 by 2324, 24 half-time rule of independent abstinence. Its characteristic type will be 100% effective plant tall, whereas the gene type will be 1:1, i.e. 50% homozygous long hit and 50% heterozygous will be long TT. 1. Test hybridization. In this, the F1 generation TT plant is hybridized with an ineffective parent TT. Both the trait and gene type are similar, 1:1. That is, 50% heterozygous will be tall TT and 50% homozygous dwarfs TT.